Hello, my dears. How are you? I'm very fine, thank you to get. I'm called Mr. Rasnaka Hailo from Ethiopia. I'm doing my job at Western University as physics lecturer. Dears, I'm requested to do this problem. Can we do together? Thank you. What he says? Oh, the problem says the density of the mercury at 0 degrees Celsius is 13,600 kilogram per cubic meter, and then its cubical expansion coefficient is 1.82 times 10 to the power of -4 per degree Celsius. If so, we requested to find the density of the mercury at 15 degrees Celsius. Great. Look, my dears, as we know, the only liquid metal is known as mercury. Yes, mercury can expand while the temperature increases. That means the initial volume of the mercury never be equal with the final volume of the mercury at a certain degree Celsius, despite the fact that the masses at any temperature level never be changed. And hence, that means the density, the initial mass at 0 degrees Celsius and then the final mass at 15 degrees Celsius is quite the same. So their solution, the mass of the mercury at 0 degrees Celsius should be equivalent with mass of the mercury at 50 degrees Celsius. Let it be final mass. Great. But, my dears, we know that density is equal to mass over volume. Great. From this we understand something. What's that? From this we may derive something. What that? Mass is equal to density times volume. Great. If so, rather than writing M or something, we may write by replacing the mass by the product of density and volume. So rather than writing the initial mass, also called the mass at 0 degrees Celsius, we may write the density of the mercury at 0 degrees Celsius times the volume of the mercury at 0 degrees Celsius. And then this should be equivalent with the product of the final density and then within the final volume of the mercury. Correct. But as what we have discussed earlier, yes, mercury can expand, so that expansion of the mercury there at temperature of 15 degrees Celsius. Just, my dears, this one, P final is equal to initial net 1 plus gamma times change in T. This is the final velocity of the mercury. Let it be at 15 degrees Celsius. Why so? Because mercury can expand. Therefore, the mass of the mercury at 0 degrees Celsius, and then the final mercury at 50 degrees Celsius. Dot. Rather than writing this one, we have to substitute this one. That is V naught into 1 plus gamma times change in T. Then this is cancelled. And then final density. That means the density at 50 degrees Celsius becomes the initial density of the mercury at the 0 degrees Celsius and then over 1 plus gamma times change in T. But the initial density is already given to us. That is 13,600 kilogram per cubic meter. And then the whole over 1 plus 1.82 times 10 to the power of -4 per degree Celsius times 50 degrees Celsius. Now degree Celsius cancelled by degree Celsius. And then multiply 50 by 1.82 and then divide by 10,000 and then add, and then you will get 1.0091. So the final density of the mercury becomes 13,600 over 1.0091 and then kilogram per cubic meter. And then just divide 13,600 to 1.0091, and then you will get 13,477 kilogram per cubic meter. This is the density of the mercury at 15 degrees Celsius. We did it. That's what you have seen. Please, my dears, don't forget to subscribe my channel and then put your own feeling up on the box, up on the comment box. Thank you for watching. Bye-bye.